Supplemental math videos from Circle Christian School.
Special right triangles. Special it. These are totally made to do without a calculator. Cool! A little bit of a reminder of what happens with the radicals. With the specials here, what to do is rationalize the denominator. That means make it real, because a radical down in the denominator is just illegal. So what we do is make an equivalent fraction, much like 1/2 is equivalent to 3/6. We multiplied both of those, the 1/2 by 3, to make the equivalency. So we're going to do the same thing here. We're just going to multiply it by a like radical, because any radical multiplied to itself always equals the number underneath the radical. And so it's much more proper to have the square root of 2 over a real number 2. And do the same thing to the next one. Just got to get rid of the radical. And so we end up with 4 square root 2. And we have 2, and we have to multiply the radicals together into 2, which is going to be a 4. And the last thing that you have to remember is that all fractions have to be reduced, so you have to look on top and below and see if there's not some way to make it a little bit smaller. Real number to real number, radical to radical, letter to letter. Moving along. Going to do the same thing here. We got a 3 square root 2 and a 6 times the radical, which is times 2. Let's see, the 3 can go into the 6 2 times, and that's just fraction reduction. And those are our answers. There are 2 types of special right triangles. The first one's isosceles. Isosceles right triangle means that 2 of the sides are equal to each other. The 2 legs are the same value. And then we always have the hypotenuse over here. And the angle ratios are 45 and 45, because isosceles triangles have congruent base angles. We call this a 45, 45, 90. Or if you want to be really cool, you call it an isosceles right triangle. And the side ratio makeup is the leg, which is x, the leg, which is x, and the hypotenuse is always whatever the leg is times the square root of 2. On a scalene right with a 30-degree angle, and it can have either 30 or 60, because the 2 angles inside of a right triangle always have to equal 90 degrees, is a 30, 60, 90. That's what we call it. And the side ratios are x times the square root of 3. My circle didn't work there. And 2 times x for the hypotenuse. So the way this goes is small leg, because it's across from the 30, medium leg, because it's across from the 60, and then the hypotenuse. Let's solve a few of these. What you always need to ask yourself is it a special right triangle? And if it is, which ratio are you going to use? The 45, 45, 90 or the 30, 60, 90? Let's start with a few of them on the 45. All right. So if we have a side value of 2, then the other side is going to be 2 because it's isosceles. And then the hypotenuse is going to be that side times the square root of 2. Easy enough. We can also be just given a hypotenuse. So for instance, maybe we have 3 to the square root of 2, which means the sides are going to be the number in front of the square root of 2, a 3 and a 3. See? No calculator. Sometimes it's not quite as apparent because maybe we've got something like, oh, let's say the square root of 6 for a side, which means the other side's going to be the square root of 6, which means the hypotenuse is going to be the square root of 6 times the square root of 2 equals the square root of 12, which needs to be reduced. You know, it's like a 4 and a 3, or even a 2 and a 6. A 4 I know is a perfect radical, so a 2 is going to come out, and a 3 stays inside. So our hypotenuse is 2 to the square root of 3. Likewise, it's possible that the hypotenuse of the isosceles right triangle isn't exactly something pretty. So say, for instance, it's the square root of 5. And we have to go back and find the sides. Looking at it, what you had is to go to the hypotenuse, the side, which is x, was multiplied by the square root of 2, and the result was the square root of 5. So to get the x all by itself, we're just going to divide out the square root of 2 and divide out the square root of 2. So we know the side is the square root of 5 divided by the square root of 2. Just going backwards, divide. Well, unfortunately, 5 to the square root of 2 has that little illegal guy down below. And so we're going to have to rationalize it and multiply it by the square root of 2. So we end up with the square root of 10 over 2 for our sides. Now we can actually prove this out. Since it's geometry, let's prove it using the Pythagorean theorem, that if we had a squared plus b squared, we're well aware of the fact that it equals c squared. So I'm going to take my two sides that I had, the square root of 10 over 2, and square them, the 10 over the 2 squared, and let it equal the c squared. That's going to give us the square root of 10 times the square root of 10 is 10. The square of 2 times 2 is 4. So we end up with 10 over 4 equals the c squared equals 20 over 4 equals 5 equals the c squared. Just follow along with me. And then we have to square root. And there we are. Our hypotenuse, which is the square root of 5. 30, 60, 90. Very similar. You just start with whatever the small side is. Say, for instance, it's 2. And then we're going to walk to the medium side, which would give us 2 times the square root of 3. Then we're going to go to the hypotenuse, which is going to be twice as much as the small side. So 2 times 2 is 4. We can also start with the largest side, the hypotenuse. So say, for instance, it is 5. So we're going to go back to the small, which is half as much, and then to the medium, which is times the square root of 3. We can even start with the medium side here, which might be, let's say we have 9/5 square root 3. Then again, we'd go back to the small, factor out the square root of 3, which would mean this is 9 over 5. And now we're going to go to the hypotenuse, which would be twice as much, or 18 over 5. Sometimes we end up with radicals. So let's say that the small side is 2 to the square root of 2. Go to the medium, and it would be 2 square root 2 times the square root of 3, or 2 square root 6. And then we're going to go to the hypotenuse, and it's twice as much, so 2 times 2 is 4 to the square root of 2. Number to number, radical to radical. Is it possible that it ends up being a really strange radical anywhere inside here? Certainly. Let's say, for instance, that our medium side is, let's make it a whole number and let it be 5. Which means now I have to go back to the small side. And you have to think again, what did it take for the small side to get to the medium side? Well, we took that small side, multiplied it by the square root of 3, and it gave us 5. So we're going to have to divide out, the square root of 3. There we go. And divide out the square root of 3. So our small side is 5 to the square root of 3. And that being illegal means that we would have to multiply it by the square root of 3 and the square root of 3, which would end up giving us 5 square root 3 over the 3. And now we're going to go to the hypotenuse here, which is going to be twice as much. So 10 square root 3, 5 times the 2, over the 3. And if at any time you have a fraction of real numbers that needs some reducing, or a radical that needs to be simplified, you'll have to do that. Okay, is it special? Which ratio are you going to use?